Hello guys, today in this video tutorial I will be introducing a new sensor, that is ADC081C. Now to gain more knowledge about this sensor, let's visit the website, that is controleverything.com, and here we have to search on for this sensor as you can see on my screen. And here we go. As you can see, it's a 8-bit 1-channel high-speed ADC, analog to digital converter, and as you can see these are some of its more prominent features. As also, you can purchase this sensor from this website, from here. Furthermore, I will be interfacing the sensor ADC081C with a Raspberry Pi and a Python code, and to get that code, let's go to Resource tab, and here comes the Python code sample. Now you can download this code sample as a file from here, just right there, and also you can have the code from github.com, and you can download the code from the repository, that is Control Everything Community. Now, as we are done with this part, now we require to make some connections. Well, in the hardware setup for the connections, what do we require is this Raspberry Pi, which you are able to see on my screen, and these are the GPIO pins of the Raspberry Pi. Next, we require an I2C Shield, which you can see, and it's available on the website controleverything.com. The real reason we are using this shield is to make easier connections with other I2C devices. So for that, gently place the I2C Shield over the GPIO pins of the Raspberry Pi and make a connection. Next, we need to power up our Raspberry Pi, and for that we require a micro USB cable just like that, and gently insert it over here, the power jack. And for the internet connection, there are two options. First of all, this here is an Ethernet cable or a LAN cable. Now gently insert it over this Ethernet jack, and you are done with the connections part. Now for the other internet connection, we can also have a adapter, a wireless nano USB adapter, just like that, and you can have on the USB port. Now next we require our sensor, that is ADC081C, and this here is our connecting cable. Now to make a connection among the sensor and the cable, we make sure that the ground terminal of the sensor should be connected to the brown wire of the cable, and similarly this rule has to be applied to the I2C Shield. So as we are done with the connections part, now our requirement is of the explanation of the code, so let's have it. So for the interfacing section part, first of all the step is to log in to github.com, and here we have to search for the repository, that is Control Everything Community, and after that we have to search for this sensor, that is ADC081C, and here comes the Python code. Now let's have a look over the instructions. We need to pull up this together. As you can see, we have to download and install SMBus library on the Raspberry Pi, and this link will help us to install SMBus step by step. As you can see, all the relevant commands, dependencies and instructions are there. Please do it carefully. After that, we have to run the code, which is here. This is the command to run the code. Note it down. And let's get back to the Python code. It's a .py extension file. Now in the code, as you can notice, we have imported SMBus and time libraries, and we have the address of the sensor, that is 0x50. Coming to the writing section part, we are going to select configuration register having address 0x02, and the command which we are going to send is 0x20, and it's for automatic conversion mode enabled. And here comes the writing command. After that, we are going to read data back from the sensor. It's 0x00 register. We are going to read back 2 bytes of the data, raw, ADC, MSB and LSB, and reading section is here. After that, we are going to convert the data onto the 8 bits, which you can see along with the relevant formulas which we have seen for the data sheet of ADC081C. At the very end of our code, we have the output data to be described and printed onto the screen, which you can see as the raw value of the source. It's a raw ADC value. So this is how the code looks like. Now let's have a look over how it works. Now coming to the very interesting part, that is to check for the practical of this code. We have to copy this entire code. As you can see on my screen, we have to copy this code of Python, and we have to open up the terminal for the Raspberry Pi here, and here we have to create a new file. As you can see on my screen, .py will be the extension of this code, and let's paste this entire code, and then we have to save it, and this is the command for the running of this code. As you can see on my screen, we are going to have the value of the raw value of the input source. It's almost 0 because there is nothing connected on to the terminals for the sensor. But instead, when I try to connect it with a AA battery of 1.5 volts, now when I run it, you can have the value of the source, the raw value, which is exactly 46, and when I run it again, you can have the values which is constantly almost. So this is how the sensor works. Now the next step is to look over the applications, benefits and the features of this sensor. The ADC081C is a low power monolithic 8-bit analog to digital converter that operates from a plus 2.7 to 5.5 volt supply. The converter is based on a successive approximation resistor architecture with an internal track and hold circuit that can handle input frequencies up to 11 MHz. Due to these variables and a lot of features, a lot of applications are dependent on this sensor, which includes system monitoring, peak detection, portable instruments, medical instruments and test equipment. Well, you can have this sensor and you can purchase it from controleverything.com, and you can get the code from resource tab. From this site, you can download the code as a zip file. Also, you can get the code from github.com, and the repository there is Control Everything Community. In the end, I would like to make it clear that if you have any doubt regarding any part of this sensor or video, you can have your queries on controleverything.com, and you can post your comments on the community page on this website. For articles and blogs, you can have a look over on instructables.com, and to subscribe more video tutorials like this, you can have a look over our YouTube channel. In the end, I hope you enjoyed this video and had a good one yourself. Thanks a lot for watching.